So we are in section 1.4. We're continuing to talk about the slope-intercept form of the equation of a line. Already we explored what the slope was and how to write an equation of a line in point slope form. So now we're looking at an alternate way to write the equation of a line in what's called slope-intercept form. And the reason it's called slope-intercept form is because you can clearly see the slope and the y-intercept just by looking at the equation. The slope is going to be the coefficient on the x. So it's the coefficient, the number that is attached to the x. And the y-intercept is going to be the number that's by itself. The y-intercept is going to tell you where it crosses, where the line crosses the y-axis. So if I had a problem that said this, find the equation, and I'm abbreviating equation EQN, of the line in slope-intercept form, that has a slope, so with a slope of a -4 and a y-intercept at, now it may say at 3, or it could say at 0, 3. 0, 3 is the x-y ordered pair. Then all I have to do is write out the slope-intercept form, and then where I, in the problem, where it tells me the slope, I'm going to put that in place of m, so slope of -4, and where it tells me the y-intercept, I'm going to put that in place of b. So the y-intercept in this case is 3. Now, and that's all I need to do, and I'm done. So I'm going to plug in -4 for m, so -4 for m, and I'm going to plug in 3 for b. This is the equation of the line. So I would say, okay, the equation of the line that has a slope of -4 and a y-intercept of 3 looks like this. So that's all I need to do. Now, can I take that and graph the line? So how do I graph the given an equation in slope-intercept form? So what you can do is you can graph the line. You're going to plot the point containing the y-intercept. So you're going to pick out the y-intercept. We know that the b is the y-intercept. And you're going to plot that point. So on the y-axis, you're going to put a point at 0b. Then you're going to obtain a second point by using the slope. So you're going to take the slope, and you're going to say the slope is equal to the rise over the run. In the case that we just had, the slope was -4. And you may say, well, okay, it's -4, but this isn't a fraction, so what's the run here? Well, any whole number can be written as a fraction with a denominator of 1. So I would say the rise would be -4 and the run would be 1. Now I'm going to start at the point at the y-intercept, and then I'm going to move up. So the rise goes up or down. If it's positive, it goes up. So I would go down. And if it's negative, I go down. So this one is -4. So I'm going to go from the y-intercept, I'm going to go down 4. And then the run goes horizontal. So I would run 1 over and drop the second point. Then lastly, I use a straight edge to draw a line through the 2 points. Put arrowheads at the end of the line that shows that the line continues on indefinitely in both directions. So let's take a look at this with this example. So here we have the linear function. It tells you it's a function, it's in function notation. Remember, you can replace this f of x notation with y. Now, in this, what is the slope and what is the y-intercept? So pause for a second and think, what is the slope and what is the y-intercept? So the slope in this equation is 3 over 5. It's the coefficient on the x. So I'm going to just write that down to remind myself. And the y-intercept in this case is the number that's by itself. It's 1. So I can say the b is 1, or writing it as an ordered pair, it would be 0b or 0, 1. Now, it has to be solved for y. You can't have other things on the other side of the equal sign. It has to be in the slope intercept form in order to be able to pick out the slope and the y-intercept. So step 1, so these steps that you see here are the same steps that were written up above. Plot the point containing the y-intercept. So that's what we've done. We plotted the point 0, 1. Now we're going to take the slope, which is 3 over 5, and we're going to go up from that point. So I'm just going to draw on here. Here's my point 0, 1, and I'm going to count 1, 2, 3, up, rise 3. So rise 3. And then I'm going to run 5. 1, 2, 3, 4, 5. You don't make these marks here. I'm making the marks just to see where I'm headed. So let me just draw it more accurately so I get to that point that they are. So it's 1, 2, 3, 4, 5. And then that's where I drop the second point. And then once I drop the second point, I'm going to connect the 2 points with a straight edge. So, and if this was a negative number, you would have dropped 3 units from the y-intercept. So we plot the next point and then take a straight edge to draw that. These lines, this red and blue line, are not there. Just imagine that they're gone. This is just trying to show you the direction. This is the line that has the slope of 3 over 5 and the y-intercept at 1. That's the graph of the function. How about the equation of a horizontal line? Horizontal line, remember we talked about a horizontal line in the last video. Horizontal lines have a slope that is equal to 0. So for a horizontal line, if you look at the slope intercept form, what would happen here? Well, if the slope is 0, then I'm going to replace this with 0. And 0x, 0 times x is 0. So the equation would actually simply be y is equal to b. So horizontal line has a special way to write it. Y equals b. You don't have a slope. The slope is equal to 0. B is the y-intercept. So the only thing you'll have is y is equal to some number. The slope of a horizontal line is 0. When you go to calculate it and you use this formula, what you're going to end up with is the difference between the y coordinates is going to be 0. The difference between the x coordinates will be a number other than 0. 0 divided by any number other than 0 is 0. And that's how you get a slope of 0. When you go to graph it, it's going to be every y value will be the same as the y-intercept. So you will get a horizontal line. So if this was, let's say that this is -1 and this is -2, the equation here would be y equals the y-intercept, which is -2. This is the equation of the line that I drew there. A vertical line has a different form to write it in. Remember the equation of the slope, of a vertical line, the slope is undefined. And so since the slope is undefined, it doesn't fit our typical equation. This is the equation. where A, this value here, is the x-intercept of the line. The slope, it does not appear in here. It is undefined. So if you saw x is equal to 5, x is equal to 5 is the equation of a vertical line that has a x-intercept at 5. So if this was my xy plane, here is 5 on the x-axis, so it's a vertical line that crosses through 5 on the x-axis. A vertical line, remember, the slope is not 0. It's undefined. So when you calculate this out, what's going to end up happening is you'll end up with a value, some number on top, and you'll end up with 0 in the denominator. And when that happens, you have to say the slope is undefined. So it has no slope. Remember, a vertical line would not be a function. So here are some examples. This one says to graph y equals 3 in the rectangular coordinate system. So let's draw a xy plane. And so I have to, I'd like you to pause the video and I'd like you to try this one. And then we'll do it together. So because this is a y equals a number, this fits the y equals b, which is the special line, which is horizontal. That means it has a y-intercept at 3. So the y-intercept is here, and because they have a slope that is equal to 0, that means it's horizontal. So this would be how I graph this. If I was to graph a vertical line, let's grab a sheet of paper. Let's say it said graph the line x is equal to -2. Or I think that's the one. Is that the one we did? Not sure. Let's try a different value. Let's say it says x is equal to 6. Well, when you see that, you have to say, all right, where's the slope here? Well, I don't see a y equals. I see this x equals. So that's different. This is one of those that would fall in the special line category. And so this one here is a vertical line. And that means it's a vertical line with an x-intercept at 6 and an undefined slope. Whenever you have a vertical line, the slope is undefined. So I'm going to look for 6 on my axis, my x-axis, and there's the number 6. So I'm going to put a dot there, and I'll make a vertical line through it. So this would be how you would graph this equation. This next discussion here is about the general form. The general form of the equation of a line looks like this, where you have the coefficient on the x, the coefficient on the b, and a number by itself. These are all going to be numbers. A and b are not both 0. So one of them can be 0, but not both of them. And so if you had this example, this is where we're going to start in our next video. This one doesn't fit the point slope. It doesn't fit the slope intercept form. This is the general form and how it looks. So we'll start our next video with that.